everyone. So good afternoon, good evening everyone. So as a part of PMRF TA session, so today will be on lecture will be on lecture will be on this so advanced chemical thermodynamics and kinetics. So this is the seventh session. So as usual in most of the sessions I used to take some questions and I will discuss it, and if you have more any query please let me know for regarding any questions. So this is the seventh session, so where we will talk about some rate law equation kinetics. So at most we are at the end of the of this we are at most today, we have crossed more than 6 lectures. So in this lecture it will be on advanced chemical thermodynamics kinetics. So today's question will be two question will be thermodynamics and statistical thermodynamics, and another will be kinetics. So this is the question, so where you need to just find out the vibrational partition function. So as you know, this partition function is the sum of, like, for this is a scalar, this is a scalar quantity first of all, and that scalar quantity is the summation for all energy levels, energy levels. So this is the cube vibrational, and also this is a unit dimensionless quantity, right? And as you know that this cube vibrational equal to, there are four options are there, 1 2 3 4. Out of there you need to find out this what will be the answer, and the summation of all the vibrational partition functions is going to be like not vibrational transfer, so everything is going to be 1, right? So what does this mean? This means that if you have this partition function contributing from the translation and rotation and vibration, so sum, and electronic as well, so sum of all the function will be 1, right? So that means cube vibrational obviously has to be less value of 1, right? That point one has to clear it first. Now if you see what is going, so h mu by kt in 4 cases, that this is basically exponential function, where if you increase the temperature, basically this h mu by kt has to be decreased, right? So negative sign will come, so you will stand between a and b, like first two options, right? Now how will eliminate one option out of these two, that you have to think about. What could be the possible reason for this? For that you do one thing. First you should know that if you increase the temperature high, right, then all the vibration levels will be occupied. What does this mean? This means that your most of the vibrational levels is occupied by by different, by populations at higher temperature. That means if you increase the temperature, h may be basically decreasing, right? Decreasing, but negative value is this one. So overall it is basically increasing, and this is a negative. So first will be the answer, right? So A is the answer here. So basically Q vibrational equal to 1 by 1 minus e to the power minus 8 nu by kt, right? So this is done. So what part is that if you increase the temperature, like at higher temperature, most of the populations will be more, right? Most of the excited states populations will be more, and based on that you can actually do this possible, can find out the Q vibrational levels for all those things. Please let me know if you have any question. now this is this like a cube vibrational function, but you can do one thing. Just a minute. Now if you go to the another question where you need to find out the temperature dependency property of a rate constant of a chemical reaction is written in terms of Arrhenius equation. So K is written. Now you have to find out this value. So if you take a value of log k, so that is equal to log a minus ea by rt. So from there you can say that how this temperature dependency can be calculated. So log k versus log 1 by t, right? Plot. Now Now come to the next question. So this is the same way. If you take like ln in both the for right side and left side, then you will get this ln a minus ea by rt, right? So from there you need to calculate the value. So minus ea by rt, basically this value minus 6.6250 by atm corresponding this temperature. From there you can get the value of ea 51.962 kilojoule per mole. This is quite easy and straightforward problem. So for CSI and NetGet, they used to give this this type of problem, 51.962 kilojoule per mole. So this is the answer. So answer is B. So in most of the cases, you know that reaction rate is highly reaction rate. That means sometimes this is related to rate constant, which depend on temperature very much. If you increase the T value, then obviously your rate constant will be increased. Overall rate will be also increased. next question, where you need to calculate the value of pi b square max. So assuming the cross sectional area sigma equal to pi r square, and these are the value already given. So here this pi b square max you need to calculate first. How will you calculate this? So in this question, so r equal to C2H4, so 5.2 to the power minus 19. So depending on the radius, so this pi b square max you need to calculate radius. How we will calculate the radius? So this is the formula for radius. This is a meter square, right? Now if you take a root of it, So it is coming 4.06 into 10 to the minus 10, and for hydrogen also same way, it is coming 2.9 into 10 to the minus 10. And Bmax is what? Just you add those two, right? This is called Bmax, right? So that is the Bmax at whole square. Now this radius, like from there, so R value. Now this is the R value. So based on the R value, so to find the value of phi b square m max, one need to find the R value of ethane as well as hydrogen. Okay. So in all of the cases this value is like basically this increasing value is this one. So for that we need to find out the alien value in both the sides and activation energy in 51.962 kilojoule per mole. So here the total vibrational participation is coming 1 by 1 minus e to the minus h mu by kt, and the next it is coming the value log k versus 1 by t is basically giving this activation energy. Here you need to find the value of this activation energy 51.962. Now go to here, you need to calculate a pi b square max. So and you know the value of r, that is this radius of ethane as well as this hydrogen, and based on that So you need to find the value of this r, and from there you can get the value of this pi b square max. So this pi b square max is the, it gives about this area meter square, pi meter pi r square, right? Next question, here you need to find out this pre-exponential factor. So this pre-exponential factor is the value for this rate of the reaction k equal to it is Ca by RT. So they are saying that if pre-exponential factor is this the value of rate constant at very high temperature. So temperature high means this value is very small. So k can be written as a, right? So rate constant and a value both are same at very high temperature. This high temperature, this rate constant, and both are same. This exponential and rate constant. Now coming to here, this Arrhenius equation. So this Arrhenius equation is k equal to 8 to the power minus Ea by RT, right? So they have given these two rate and corresponding to rate constant at a given temperature. Then choose the correct relation between the rate constants. Constant, constants, constant. So k1 by k2 less than a1 by a2, k2 by k1 less than a2 by a1, k1 k2 greater than a1 a2, k1 plus k2 greater than a1 plus a2. So So K1 equal to A1 e2 minus CA by RT, and followed by this one, this K2 by Q1 equal to A2 by e to the power minus e to the power minus e2 minus e1 by RT. So if you multiply this K2 by Q1, so basically you are getting Q1 by K2 less than A1 by A2, K1 by K2 less than A1 by A2. So this is the 7th question. Now coming to the next question, for a reaction with activation energy of 49.8 kilojoule per mole, so I need to find out the value for this rate constant as 600 kV, K and 300 K. K 600 by K 300, and R value has to be taken 8.3 joule per mole per Kelvin. So depending on the value this K1 K2, you need to find out this rate constant 600 and 300 K. So how to approach this problem? this 600 by 300, so this is, you are getting around e to the power 10. So ea by 2.303 are 1 by t1 minus 1 by t2, and this value is 1 by 300 minus 1 by 600. So based on this value you can get the particular one ratio. So this k2 log k2 by k1 equal to ea by 2.303 or 1 by t1 minus 1 by t2. Now here one need to find the rate constant. If rate constant is doubled when temperature increase of 27 to 37 degrees Celsius, calculate the approximate value of activation energy in kilojoules per mole. So this is the same kind of approach will be there. So the rate constant has been doubled to k2, means k2 by q1 is equal to 2, right? Equal to my ea by 2.303 minus 2.303 into r is 8.314 by a into 1 minus t1 then 300 Kelvin minus 1 by 310 Kelvin. So 310 into 300 by 300 into 310. So overall it is coming 54.2 kilojoule per mole. 54 kilojoule per mole. So B is the answer. So if you see, this is the vibrational partition function, where you need to find out the value for this vibrational partition function, which is around equal to 1 by 1 minus e to the power minus h mu k by kBT. it was that you need to calculate this 1 log k versus 1 by t plot, where you need to find out this activation energy. Now this is the plot where you need to find the value of this activation energy. So with it 51.962, so P is the answer here. Here the answer is A. Here the answer will be A, B. So 1.5 to 10 to the power minus 18. So C is the answer. Here the value of rate constant, this 1.6 into 12 is the answer. And here Q1 by K2 less than A1 by A2. So this is the answer. And here you need to find this value of this this K 600 by K 300, and this is the value for this activation energy 52.4, so 54 kilojoule. This will be B. So this is the another question where you need to find the average velocity of reactor molecule at 300 Kelvin temperature. So you know that okay, first you need to know how it is the formula for average velocity, right? So average velocity so 8 kt by pi mu. So this is the formula for this average velocity. see this k 8 kt by pi mu. So here this mu is called reduced mass. So for reduced mass, m1 m2 by m1 plus m2. So here this is CH3 ion hydrogen. So 15 into 2 by 15 plus 2. See if m1 into m2, right? If m2 greater than m1, even m2 greater than m2 plus let's 0 1, then obviously this reduce will be far more better than 1m plus 1, right? So this is the reduced mass of this 6.023 into 10 to the power 23 number of molecules, right? Now reduced must have one pair of reactant, right? One pair of reactant, that is 1.676 gram by 6.023 into 10 to the power 23. So overall your time is coming like 1.76 into 10 to the power minus 3 by 6.023 into 10 to the power 23 kg. Finally this B, that is the velocity, average velocity is coming 8 kt 1.3 10 to the minus 23 joule into Kelvin into 300 k into 6.022 into 10 to the power 23 by pi u 3.14 into 1.76 into 10 to the power minus 3 kg, and root over of that. So overall it is coming this this velocity, that like velocity is coming 1899.7 meter per second, 1899.7 meter per second. So this is the average velocity, right? So now if you increase this velocity, now this to increase the velocity, what are the procedures one need to follow, right? So this can be followed by like different kind of mass and temperature. If temperature means more, means always velocity will be more, right? So if you recap, so this is the seventh lecture, and this is the vibration of partition function, where this partition function will, the value of this partition function equal to 1 by 1 minus e to the power minus h mu by kt. And next is this one, the temperature dependency of rate constant. So it is coming of a chemical reaction is it in terms of Arrhenius equation. So it is coming that k equal to a into e to the power minus a by rt, while log k and 1 by t is the plot, right? So this is about this this is temperature plot where you need to find out the activation energy. So this is the form so this is basically k equal to a into the minus a by rt, and this is the formula. And if you see this one, so here you need to find out the pi b square, so meter square value you need to find out, and based on this finding you can do some writing on this. So this is, you need to find out this pre-exponential factor. That factor is, if there is high temperature, temperature is too much high, basically k and a are they are equal, because this exponential term is going to be 1 because t is very high, as a result of which e minus is very low, so it tends to 0, e to the power minus 0, that is basically 1, right? So k and a both will be the same here. Now come to the next question, where you need to find out this Arrhenius equation. Based on the Arrhenius equation, you need to find out so based on the so here you need to find out this equal relation between this q1 k2 and o1 a2. So here you need to find out this rate constant so here you need to find out this activation energy value, so that is 54 kilojoule per mole. And here you need to find out the reduced mass and followed by this average velocity of the overall system. So in all of the cases you can see that the first and foremost formula you need to keep it in mind is the Arrhenius rate constant equation, that is k equal to a e to the power minus e a by rt, and followed by some taking some log or ln, you can get a different medium form of that equation, and here you need to find out this average velocity 8 kt by pi mu whole to the power half. So these are the things you should take care while doing this kind of assignment for week 7. So with this I would like to conclude today's session, but we will continue in the next week, for that is the 8th week, and our end semester exam is also coming very fast, so we will wrap it fast. And if you have any query, please like comment on my channel also, so here I will upload these videos. If you have any comment like that, just let me know. By the way, so you can follow this for chemical kinetics. There is one book called Puri Sharma Patania, you can follow. I used to follow that book. Apart from, you can follow Levine, Atkins, whatever you like, right? Particularly this is a very normal problem, so this is a very good problem for CSI and NetGate. So this kind of problem people used to ask in CSI and NetGate, right? And this is for this rate constant. This is also a very standard question for CSI and NetGate PG interview as well. And this is the yes, this is also a good rate constant and pre-exponential factor relations. Yes, so this is also key. This relation between exponential factor as well as rate constant. Now it is a value for this. Yeah, this is also important value where you need to find the basically pi b square max. So b, you know, the value of b square, b equal to the sum of that two radius, right? Exploded volume kind of thing. Now this is also a good question, so where you need to find the activation energy. So if you see this question and this question, as well as this question, so all are basically that same formula, k equal to E into e to the power minus ea by rt. So with this formula you can you can solve this kind of problem, and these problems are very standard for CSI and NetGate. Okay, in MSc question paper also. So here also they can say that they can give different to temperature, even they can give the activation energy, everything they need to find the value for this what else, rate constant value. So some parameters as will give there, and then you need to find out. Otherwise they can give some ratio also of rate constant like this. So accordingly you have to approach, you have to do the answer for these questions. So in all of the cases, you know that this is very important, that you should always remember this k equal to a to the power minus ea by rt. So that is the very fundamental equation. From there you can derive many form of that particular equation, and you can apply those forms for solving your questions. Okay. Now you can so here this is okay. So if they ask for, this is average velocity, they may ask for RMS also. RMS, the value will be different, right? Root over 3 r2 by m, but here root over k 8 kt by m by pi m, right? So mu is the reduction, because you are considering two different reactant molecule and their mass is also different. So as a result, basically you are getting this value reduced mass m1 m2 by m1 plus m1 m2 by m1 plus m2. So that is the equation for this reduced mass. And this one, I have told this one. Yeah, this is the ratio. This is the like from the same formula only, just you need to find out the ratio. So this is also same. They can give high temperature, and sometimes they can give very low temperature also. So based on that you have to do. this one I've been told. Yeah, so that's all. So thank you for listening to my talk.